Hey everybody, this is Larry. This is me going with Q3 of the bi-weekly contest 74. Minimum operations to half array sum. Hit the like button, hit the subscribe button. Have a go to my Discord channel. Come hang out with smart people and me. Okay, so to this problem, it's a little bit odd, I think, to be honest, because I think for Q3, because I think Q2 was a little bit trickier. But that said, this is a very greedy solution or greedy problem because you're trying to find them. Like, I think some of that, I mean, obviously it's a greedy, maybe it's not obvious, that's why I have to explain it. But I'm saying that it's a greedy solution, and of course, with that, you should have a proof in theory, in the ideal case, conceptually. But it's obviously during contests and stuff like that, it's very hard to mathematically prove out your whatever, right? Of course, that's not gonna pay. But here, the way that I would describe how to think about this problem in terms of figuring out that it's greedy is that you're trying to minimize the number of operations every time, right? Meaning that you have a sum and you have to, and another way to phrase it is that reducing it by half, the sum, or reducing the number, one number by half, and then means the same as reducing the sum by half of one number, by half of one number in one operation, right? And of course, that if you phrase it like that, then it's very apparent that it's greedy, because in one operation you can minimize by one number, and that number you want to maximize that number. So so you just subtract it from the largest number, right? Half of that, of course. Because that's one consideration. The other consideration is, the other consideration is just that when what happens after one operation. Well, the invariant is still true. Now you have a new array or new problem. It's just that after you took one step or one operation, you have to do the same thing, right? And of course, this will, now you want to do the same thing, which is to get the largest number and then reduce it. And of course, with practice and a lot of practice, maybe moderate practice for this particular one, you see that you always you keep on every operation you want to get the max number in the array, and in that case, then that is a very natural heap solution, because there's a get max function literally, right? So that's basically the idea, and that's basically the solution. There is one more consideration that I would say, though, is that I didn't do it for this, but I was, to be honest, during the contest, I was worried about floating point precision, right? And this is something that we don't see that much on Leetcode, and we don't see that much even on Code Forces type of competitive programming, and not that much on interviews as well. So it's very easy to be not practiced on or not have that knowledge or whatever. And just getting the idea of how floating point works and stuff like that, you may worry about rounding errors or stuff like this, right? Here we are, or I am able to be a little bit more confident about that, even though I still kind of took an extra couple of seconds just to think about it a little bit, just to make sure, because these things can definitely ruin your day if you let it. I'm speaking from experience, of course, where it's just so easy to make mistakes, or assuming that all your operations on your domains that would have been true on integer is still true on floating points, because of rounding errors and error accumulation and stuff like that. I'm not gonna get into that deeply for this problem, because it's not that relevant. But the thing that I would say that allowed me to prove, and maybe enough people to YOLO and just not know and still get it right, but I hope that you understand this concept a little bit, is one is read up on IEEE standards on floating points, but one thing you should know is that because you cannot represent all real numbers in a floating point exactly, so you have to do some rounding. However, you do not need rounding, or you're able to represent powers of twos exactly in floating point. Because, well, you just have to read up on the standards. But so in this case, because we only have to divide it by 2 and only 2, we are able to, at least within reason, because it gets like 1 over 2 to the negative 127 or 128 or something like that, right? Is the smallest number that you can represent in a float. And in that case, you would start getting rounding error type things after that. However, that means that you have to divide it by 128 times or something like that. And of course, in this case, I think you do not. I think in this case, you only need like a handful of operations. But I don't even know. I think if you only have to divide the same number at most twice or something like that. I could be wrong on that one, but that's that's a thing, right? Twice or 3 times maybe the same number, so you could do other numbers as well, and maybe you could prove it by like some pigeonhole type thing. But yeah. So on that note, so that everything can be represented in this problem by float exactly. I hope I'm right and I don't get like a wrong answer after the contest on some weird floating point things. I still might. That's how not confident I am about floating point. And whenever I use it, I feel very not good. So yeah, so definitely think about that. And you could actually, if you really try, you could actually implement this with big int instead of divided by 2. I think it's still, or big int is the upper bound, but I think you could still do it without, yeah. So definitely maybe play around with that idea a little bit, because you only have to multiply the same number a couple of times. Maybe that's not true. I don't know. We'll see. But in any case, yeah, so that's basically my solution with all that talking and all that learning, hopefully, is that I put every number on heap, keeping in mind that in Python, heap is a min heap, which so I converted, quote unquote, converted to a max heap by using the negative number. This happens a lot, so hopefully I don't have to explain it that much. And if the min of a negative number is the max of the positive version of that number. So that's basically the idea. I might have said it in a weird way, but let me know. But yeah, and then now while this condition is true, I pop, I divide it by 2, I subtract it from the current sum, and I add a step, and I put the new number back into the heap, and then at the end just return number of steps. Like I said, I think in the worst case you just have every number once, so this will only be this while loop will be linear time, and this will be linear time even though linear number of iterations is obviously this is not linear time, but because each of these will take all of log n, right? So this is n log n is what I meant to say. Yeah, and that's how you would analyze it. So this is n log n time and O of n space because of the heap. Cool. That's all I have for this one. You could watch me solve it live now. What is? I mean, I was rushing it, to be honest. Maybe there was an easier way to do that. Round down. Oh no, it's exactly. That's really awkward, actually. guess it takes at most end operations. Okay, fine, whatever. Am I mixing languages? Hope I don't have floating point issues. Okay. Hey, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, the explanation, and this contest in general. Especially come on Discord because there are a lot of smart people there, a lot of top 25 people, including me. So yeah, anyway, stay good, stay healthy, to good mental health, take care of yourself, take care of others, and I'll see you later. Bye-bye.